Welcome to NASA STEM EPDC Quickbits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world. And finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Greetings. I am Dr. Samuel Garcia Jr., and I'm an education specialist at NASA's Kennedy Space Center. Today, we'll explore the activity called Touchdown. We will learn about the importance of models, and we will build a model to help us land 2 astronauts safely on the moon. The main objective is developing and using models. In this activity, the student will participate in the following exercises: developing or modifying an evidence-based model, using and/or developing a model with variable factors, and finally, developing and/or using a model to predict phenomena and describe non-visible mechanisms. In this activity, students will use what they know and can also do research about gravity, motion, and forces to design and build a shock-absorbing system that protects 2 astronauts upon landing. In the same way that engineers had to develop solutions for different landing types of vehicles on the Moon and Mars, students will follow the engineering design process to design and build a shock-absorbing model with simple materials. In this activity, students will use the engineering design process to design, build, and test their moon landing model. The first step is ask. The next step is imagine. Then comes plan. Then comes create. Then comes test. Then comes improve the design. And finally, the last step is share the results of your design. Artemis. This is the name of the program with which NASA intends to allow the return of American astronauts to the moon. NASA is building the Space Launch System, or SLS, the largest and most powerful rocket ever built to carry humans in the Orion spacecraft and enable missions to the moon and, in the future, Mars. Landing on the moon is risky. First of all, because the spacecraft can travel to the moon as fast as 28,000 miles per hour and needs to slow down considerably. This spacecraft does not carry test dummies, it carries real astronauts. Before building the equipment that will take humans into space, NASA engineers design and build models or prototypes as part of the engineering process. We challenge you to design and build a shock-absorbing system that can protect 2 astronauts upon landing. Suggested materials are as follows. If you don't have marshmallows at home, you can use some of your toys to make astronauts. Construction. First, design a shock-absorbing system. Think about springs or bearings. Have paper and pencil ready to write down ideas and sketches while you design. Design a damping system. Think about springs and cushions. The 2 regular marshmallows, or the astronauts, must be inside the cup. Draw your design. Note, the cup must remain open without lids. As soon as you assemble the spacecraft, decide what materials you will use to make your shock absorbers. Using your design as a guide, assemble your landing model. Ready to test the design? Drop the spacecraft from a height of 1 foot. If the astronauts sway, think about how to improve your design, study any problems, and redesign. For example, if your spacecraft ejects the astronauts from the cup as problems arise, study and redesign, then try again. Add soft bearings or change the number of position of shock-absorbing parts. Also, make the springs less powerful so that they don't eject the astronauts. If your design flips while falling through the air, Make sure it is level when you drop it. Also, make sure the cup is centered relative to the piece of cardboard. Which model worked best? Why? What variables affected the quality of your design?
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.